this video, we are going to see how to find the longest common subsequence of given two strings using a dynamic programming method. So the problem specified here is if you're given with two sequences, okay, we have to find the longest common subsequence. So subsequence means if I'm taking a string as shown here, I'm taking A, B, C, D, E, F, G. Normally, the substring means the continuous characters from any particular ith position to jth position continuously. If I'm taking any subpart of the string, that is actually substring. But if I'm taking subsequence, it can be from ith character to jth character, where j will be greater than I. Any in between characters can be missed, but the order of the characters should be as in the given string. For example, here, if I'm taking A, B, C, D, E, F, G, ABC is a subsequence. Similarly, ABG is also a subsequence. If you take AB, A, after then I'm having B, later only I'm having G. In between characters are missed, but still it is a subsequence. And similarly, BDF, AEG. So these are the subsequences of a particular string. But when I'm talking about common, I'll be at least having two strings for which I have to find a common subsequence. And here the optimization is I need to find the longest common subsequence. Okay, so for that, the dynamic programming formula we are going to apply is usually in dynamic programming, we'll be constructing table. The values will be recorded for the smallest subproblem, and then that value will be used for the next calculations. Okay, so for that, the table to be constructed, the formula to be used is here. We have to construct this C of ij matrix. The size of the table will be, if I'm having two strings, so if I'm having two strings, for example, x is of length m and y is of length n, then the table will be of size m plus 1 by n plus 1. Okay, one extra row will be having, which is initialized with 0. That is the base value we are going to start with. Okay. Okay, then the formula applied is here for the zeroth row and for zeroth column. For zeroth row and column, we'll be having the value as 0. And for the other columns, we are checking the corresponding characters, ith character and jth character of x and y respectively. And if they are equal, then with the diagonal value, I minus 1 and j minus 1 are representing the diagonal value. With that, we need to add length 1 more. Okay. Till I minus 1 characters, some count is already matched. And now we are having one more character matched. Hence, it is incremented by 1. Otherwise, if it is not matched, we are going to take from the previous column till I minus 1 character how much is matched, or till j minus 1 characters in y how much is matched. So we'll be taking the value from the previous column and the previous row, which is maximum, that will be taken. Okay. And we have to find this value, completely construct this table till the value for m by n. Then this will give the length of the longest common subsequence. Then by traversing it back, we'll be finding what is that subsequence. So let's directly apply this in a problem and we'll find the solution. Okay. So consider two strings. X is given like this, ABD, CBAB, and Y is given like ADC, ABA. Okay. So this is the string X and Y. Okay. And we are having one more extra row and column, which is initialized with 0. Okay. And from here on, as we start comparing the values. So when I'm doing this for this particular cell, I need to compare x of 1 and y of 1. If it is equal, I need to add 1 with the diagonal value. Okay, the corresponding cell values are equal, the x and y values are equal, then with the diagonal I am adding 1. And let me also trace where I am taking the value from. Okay, and then row wise let us construct Next here, if I need to compare A and B not equal. If not equal means I have to take the value from the previous column and previous row, which is maximum. That value I have to consider, which is maximum. One is maximum. So here I have taken the value from the uh, previous column. So the arrow should denote to this position. Okay, I'm taking the value from here. So I'm denoting this. And also here, let me use the other side, common arrow. So this one is constructed from here. Similarly, if we go to the next position, A and C not matched, then I have to take the maximum, and this is the maximum value 1. Then A and A again matched. If matched means I have to add 1 with the column, diagonal value. Then A and B not matched, the maximum is 1. So it is taken from the nearby column. Then A and A matched again. So from column diagonal value we are adding 1. Next row let us construct. B and A not matched. Then I have to take the value from the previous column or previous row. Previous row is greater. Hence, let me take the value from the previous row. So it is 1. And the next row B and D not matched. Take from anywhere. Both are same. So let me take from the left side 1. You can take from any side. Then B and C not matched, take from any side, let it be 1. Then B and A not matched, take from any side, 1. B and B is now matched. So now with the diagonal value, I have to add 1. So it will become 2 now. Then again B and A not matched. Now the maximum is from the previous column, so 2. Similarly, next D and A not matched, take it from the previous row. Then D and D matched, then take it from the diagonal value. Then D and C are not matched, take it from the column which is maximum. Then D and A not matched, take it from the previous column. D and B not matched, you can take it anywhere from row or column. Then D and A not matched, you can take it from anywhere in the row and column. Let me choose a column. Okay. And then C and A, next row C and A not matched, take it from the maximum row. Then D and C not matched, maximum is taken from the previous row. C and C matched. Now you have to add 1 with the previous diagonal value. And then C and A not matched, maximum is here. Then C and B not matched, maximum is here. Then C and A not matched, the maximum is here. Similarly, let us complete this table. B and D not matched. Then D and C not matched. Then B and A not matched. B and B is matched, so let us add it with the diagonal. And B and A not matched. Okay. Then A and A matched, so 1 from the diagonal. Not matched from the row. Not matched from the row. Then matched, so from the diagonal. Then not matched, you can take it from row or column. Then matched again, so from the diagonal. Then here not matched from the row, not matched from the row, not matched from the row. Now again not matched from the previous row. Then matched now, so it will be 5, the diagonal. Then A and B not matched, so you can take it from anywhere. Now what we understand here is the common subsequence length, the longest common subsequent length is 5. Okay. Now to find what is that longest common subsequence. Okay. So for that, we need to backtrack. We need to backtrack this table. So last value I'm having here 5. Okay. And consider this. Here I'm having this 5. I have to check whether it is the same as the previous one or I have taken from the diagonal value. Okay. And now it is taken from the previous column. So I'll move to here, and here I'm having this. Okay. So let me take this value B as the last character matching for this 5. And then since I'm giving this direction diagonal wise, I'll move here. Okay. And here also I'm having diagonal value. Here I'm getting this A and A matched. So I'll take the previous value as A. Now travel to the diagonal. I'm having 3, okay, and it is not changed, okay, it is not matched. And now next it is moving to the previous one. When I'm meeting it with the diagonal, then I'll be taking the corresponding value, okay. So now I'm moving upside, I'm not taking the character, and now I'm having this diagonal arrow, which means the corresponding character, the header character, what I'm having, C, or from the column, so C. And next we are moving to this position. Here again we are having the diagonal value. What is the row and column header? D. Then we are moving diagonal, okay, but here we are having the value taken from the upper side, so move there, and there we are having the diagonal value, so that corresponding character has to be taken, okay. So we start from the last cell. Whenever we are having the direction to diagonal, that row header or column header can be taken in the subsequence. So we are constructing the string in the reverse order. So when we reach here, we complete the string. So this is one of the longest common subsequence of length 5. We can have some other also, because we are not taking every direction. When I'm comparing the previous column and row, if both are same, I can take either from the column or from row. For example, here itself, when I'm filling this particular value, both previous column and previous row are having the same value. So here I consider from the previous column. Instead, if I have taken from here, then I'll be having a different string which is ended with A. Okay, so there are possibilities that we can have more than one longest common subsequence, but this is the method we can construct. If we store both the directions, we can find out all possible longest common subsequence.